Hello, everyone. Welcome to our webinar. This is my first webinar with Oso, so I'm pretty excited. The 10 types of authorization. My name is Hazal. I'm here with Sean, my teammate. We are both developer experience engineers at Oso, and today we're going to just facilitate the webinar for you. We will help you understand the 10 different types of authorization models, and these are types within role-based access control, relationship-based access control, and attribute-based access control. I'm sure you heard of these terms before, but we are going to go in depth of submodels of these access controls. These models provide you a robust framework for precise access control, and it aligns your security with the application's complex interactions. The agenda of our webinar will be the 3 different models and their submodels, and then we're going to talk briefly about application and integration, and we will go through our demo and Q&A. Let's start with the RBAC models. This is role-based access control. It is a security model that assigns permissions to users based on their roles within an organization. This allows or restricts access to the resources accordingly. The first one we're going to talk about is the global roles. This model gives users the entire application and access to that entire application regardless of the resource. As you can see in the code example, there's a global role that is admin, and that admin basically gets permissions for everything. An example of this would be super admins, which can access all organizations or accounts, unlike general members. Or another example would be, as a developer experience engineer at Oso, I have global permissions across the entire Oso platform, which gives me the ability to manage resources across teams without being limited to my specific department. The second model we're going to talk about is organization level roles. These are roles that apply within specific organizations or tenants. Here, the users are assigned roles on the organization that they belong to. At Oso, we call these multi-tenant roles. You can think of this logic as a user has a permission if they're granted a role, and the role grants that permission. An example of this would be admins in a B2B application can add users while members have restricted access. So if you're just a member, you may not be able to add a user, or you may not have in-depth permissions. Another example would be, since I belong to a specific department at Oso, I have the admin role where I can organize events or access restricted internal tools, while other team members may have lower permissions, given that they're not in my specific department. In the code example, you can see there's the resource organization, and there's specific roles and permissions that are assigned to that organization. The third one is resource-specific roles. Almost every application first starts with roles at the organization level, but very fast you will realize that this is a very limiting model, since it only allows you to grant access to all of the resources that are in the organization. This doesn't really allow you to pick and choose what people can do or see. A natural way to provide more fine-grained access would be to extend the concept of roles to other resources in the application. An example of this, which you can see from the screenshot, would be Google Docs, and they have viewer, commenter, editor type of roles for each of the documents. So instead of you giving access to your entire Google Doc drive to someone, you can do specific permissions for specific documents that you have. Another example would be, while working on this webinar slides, only me and few colleagues had editor permissions, while the other people could view the material without making changes. And the fourth one is custom roles. Some applications usually reach a point where there is such diversity in how different organizations want their users to engage with features that it becomes impossible to anticipate all of their needs. And it's basically very hard to implement predefined roles that capture every use case. So sometimes you have to create a custom role that assigns custom permissions for specific people. An example of this would be Microsoft Azure, which allows users to define custom roles for their organization. Or another one would be, in Oso, we could define a partner advocate for our key business partners, which would give them access to maybe a subset of our documentation or authorization policies that other people may not have access to. Now that we're done explaining these RBAC models, let's look at some industry examples like GitHub, Slack, and Jira, which I assume many of you used before. GitHub. GitHub resource specific roles to manage access to repositories. Admins here can set permissions at the organization level, so I may have access to entire repositories of Oso, while maintainers and collaborators are assigned roles at the repository level. So as you can see in the screenshot, I can give direct access to a repository that I have in my GitHub. In Slack, they implement RBAC with custom roles for enterprise customers, allowing them to define user roles such as workspace admins, owners, or custom permissions for managing integrations and apps. They also have specific tiers. You can be a free Slack user, or you can have the premium account, which would automatically give you different sets of permissions. And Jira uses RBAC to manage user access to projects. They also have different type of permissions for issues and dashboards, and users can be assigned to roles like project admin or developer, and these would be within each project. So you would have custom roles often created for specific team needs, and if you're in the marketing team, maybe you're in the marketing board. If you're in the engineering team, you will be in like an engineering board, and you will basically have different types of permissions depending your role. ReBAC models. This is relationship-based access control. It is an authorization model that grants or denies access to resources based on the relationship between the users, and like we call them actors, and resources. And this would allow for more dynamic and context-sensitive permissioning. The first one we're going to talk about, which is the fifth one overall, is actor and actor relationships. These are between users of groups. So if you have a lot of users, then it will be easier for you to manage access for entire groups of users rather than assigning roles individually. With Oso Cloud, you model this with a rule that allows members of a group to inherit any role assigned to the group. So if I join this team, instead of giving me what can Hazal access, they can tell also has Hazal in this team, and then I would automatically inherit all of the permissions of that team. Another example of this would be an incident response group having access to all of the permissions of its subgroups, such as HR group or operations group. Or another examples would be like I collaborate with the marketing team and I have access to resources from both my team and theirs. So we can tag as like, is Hazal in marketing team? If I'm in the marketing team, then I will automatically get access and permissions for those. The sixth one is resource and resource relationships. These relationships are between resources in a hierarchy. So this commonly expresses roles and permissions that cascade down this hierarchy, such as files nested in a folders in a file system. A real life example would be GitHub, as you can see in the graph. So you may have an organization, and this organization may have different repositories in it, and these repositories would have folders and files in it, and the permissions would be flowing downwards. So if you have permissions to see and view and edit the organization, then you will automatically get access to everything that's in the repository and in the subfolders and files. Another one would be that this webinar resource is part of the larger developer education resource. And if you have access to developer education resources, then you will automatically be able to see the webinar content as well. The seventh one is actor and resource relationships. This defines relationships between the actor, which is the user, and then the resource, which is the file. Many applications want to grant special permissions based on the relationship between a user and a resource, such as allowing a repository's creator to delete it. In Oso Cloud, these relationships are encoded as relationships between the user type and the resource type. An example of this would be if a user submits an expense report, they can view it, but no one else can unless they were giving that permission. Or I, which is the actor in this case, have editing permissions on this webinar content I manage, which is a resource, but only viewing rights on reports generated by others. This is tied to the relationship between me and then that specific resource, which is the report that other people are building. And our last but not least general model category is ABAC. It's attribute-based access control. This is an authorization model that determines access to resources based on the evaluation of attributes. The attributes could be user roles or resource types or environmental conditions and more, and policies, which allows for fine-grained and flexible permissioning. The first one is attribute checks. Attributes checks are basic comparisons of attributes on resources or users. For example, when managing my GitHub repositories, I might set certain projects to private or public based on their sensitivity. This simple check of an attribute controls access to my code. So if it's a private repository, you won't be able to see it. And the same conditioning applies to Google Docs or Dropbox or anything like that. The ninth one is attribute add-on. These are additional conditions layered on top of other permission checks. So an example of this would be that a user can create private repositories if they're in the organization, and only if the organization allows private repositories. Or while working with an internal Oso project, access to feature branches might depend on my role, such as an engineer, and whether I am part of a feature development team. So only team members can push changes if both conditions are met. If I'm in the marketing team, I may not be able to see that specific branch. And the last one in the ABAC models is custom policies. These are fully customizable and dynamic policies that lets users define their own logic. For example, I may create custom policies that allow specific team members to access restricted parts of the project only during the testing phase and maybe not in the production phase. This includes conditions like access only during specific hours, or you can only approve changes if fewer than 10 lines of code are modified. Another example would be a DevOps platform that controls repository access, where senior engineers could approve all of the branches, but junior people can only approve non-production branches, and maybe contractors have read-only access to non-confidential repos for only a specific period of time. It's also important to mention that, like, even though this is a type of authorization that we have in the webinar, this isn't something that also currently supports. Application and integration. It's important to know that these models don't really exist in a silo. All of these are related, and the attributes and relationships and roles that you have will usually intersect. And in production, you will most likely to blend many authorization models together. And let's look at a sample app that uses these authorization methods. So I'm gonna stop screen sharing so that my colleague Sean can demo his sample app.
Thank you, Hazal. Great. Can everybody see this all right? This should just be GitHub. Cool. So for the last few weeks, I have worked on building out a sample app that uses a bunch of different authorization patterns. This is available as a public repo on GitHub, so you can pull it down, you can run it, but more interestingly, you can look at the code because it's open source. And we're calling this a reference app. So a lot of sample apps that are built are glorified hello worlds or don't really deal with the complexities of having a real data model that you're trying to do complex things with. And I've always found that very disappointing. So what I wanted to do was build something that was a little bit more like an actual reference that had a bunch of inline documentation and showed the software being used in a more realistic scenario, right? This isn't something that we contrived to fit what Oso can do. I had a kind of top line idea that I wanted to build a somewhat, service-like app and then make sure that Oso could support it. And unsurprisingly, it could. One of the cool things about this app, which we'll get into in just a little bit, is that it's a fully multi-tenant app, which is, Oso was built to be authorization as a service for SaaS companies. So that totally works. We also have the ability to control those tenants, which is cool. We're users within those tenants. And we're able to impersonate different users. So we're able to see the application as any given user would see the application. And we've done all of this using what we call local authorization in Oso. If you aren't super familiar with Oso, the way that it works is that you have your policy, which expresses the logic of how you want your authorization to be enforced. We think of that kind of like the control plane. And then you actually have to give the policy data of some variety that expresses the state of the application. And the reasoning behind that is that, the policy moves at one impedance and the data moves at another. So for instance, you probably only want to deploy a policy, I don't even know, like we'll say once an hour, once a day or something like that. But the data that actually affects an individual user's access to an application, that can change, as quickly as a database write. So because those two things kind of move in different impedances, those things are totally separated from one another. So with local authorization, you still have your one policy, and we'll get an example of this in just a sec. You get your actual policy, but then the data that you use, the kind of data plane that interacts with the policy, all of that stuff is driven out of a Postgres instance. So what this application does, and we'll show you, is that we're actually able to manage all of the authorization data using a local Postgres database. So that way you don't have to worry with things like syncing data to Oso or, any of the complexities that come up with that. So the actual application that we have here is going to be a file sharing application. And as we go through and actually use the application a little bit, that will kind of spring to life. But let's start by looking at the actual policy. So like I mentioned, yeah. So like I mentioned, you keep your actual policy in a Polar file. Or I mentioned that there is a policy. We use a language called Polar, which is a home-built DSL for actually expressing authorization logic. So for this application, we have the organization resource, and this is typical for any kind of multi-tenant SaaS application. And Hazal talked about this, that we have organization level roles. And these are meant to be the kind of biggest bucket of things. So, you don't have not everything is partitioned by user, but it's partitioned a little bit more by organization. So we also have global roles, and this is a convenience feature that will let us have, in our app, you'll see this in just a sec, we have one specific pseudo organization that actually is our global organization that lets us control everything. We also have users, which is more or less as you'd expect. These are just the people that actually do things in the application. When we're in it, unless we're in the super impersonation mode, we'll always be viewing things as a user. And then, like I mentioned, that this is a file sharing application. So we also have things that are modeled as documents. So hopefully this was everybody's familiar with Google Drive or whatever, and this is a somewhat easy enough mental model to keep in mind that we have tenants that are organizations, users that are kind of within those tenants, and then there are documents that are also within an organization that users have roles and permissions and stuff on. So the first thing that I wanted to talk about was just kind of general RBAC stuff. So like we mentioned in the presentation, we have global roles, and this is meant to give you a way of kind of simply instrumenting that there will be some users with some permissions or some roles that are meant to just be accessed everywhere. So an example of this in our application is in our resource for organizations. We have a special role called admin, which essentially just propagates that any global admin is also an admin on all organizations just by default, which makes it convenient for if you're accessing things as a global admin that you can go in and, kind of do anything. But we also have this other permission for global admins called create. And this is a little bit of like a hacky bootstrap thing that just allows our global admins to create organizations themselves. There's a kind of chicken and egg problem here that this, papers over a bit. So when we launch our application, we are in this kind of default user space. And this will show us that we have these are all of the users that exist and are available to us. So the first person that we'll impersonate will be our root user. So we pop things open as our root user. And we see here that this organization that's the underscore is our special bootstrapped global organization. So anywhere that you see this kind of underscore, you can just kind of blur your eyes a little bit and pretend that it just says like global or something like that. And those things will always correlate to how members of the global organization are managed. So root within the global organization has an admin role. And then we have a little readout of all of the permissions that this user has on this resource. So they can read it, they can create new organizations, they can create users, and they can create documents. All of this makes sense. They're an admin on this organization, but they're also a super admin. So we expect them to have these kind of permissions everywhere because of how we've, constructed the policy. So because we can create an organization as a super admin, we'll create a new one called Acme. We'll add the organization. And if you were really closely paying attention, you'll see that React redrew this little organization dropdown, and we can now create users within the Acme organization. So what we'll do is we'll create Alice as as an admin on the actual Acme organization. Now what we're going to do is kind of jump into more typical user space of what the application does. So we'll jump in and pretend to be Alice. And at any time, you can always see who I'm impersonating. Maybe I'll blow this up a little bit. You can always see who I'm impersonating up at the top here. Every route in this app is prefixed by user and then the actual username. So viewing this as Alice. So Alice has the permissions that, we've talked about so far, that she can read the organization, she can create users, she's an admin, she can create documents, she's a member, but she can't create orgs. And this is the kind of first place that we're seeing this differentiation in role-based access control. That we know that Alice is an admin, but Alice is not like a global admin. So she has slightly different permissions than the root user does. And just to reinforce that, we can see here that on line 14, you're an admin if you're a global admin, and only global admins have the create permission. And create there maybe should be create organization, but close enough. Cool. So Alice is able to add users, but Alice can only add users to her own organization. She can't add users to any organization. So how do we figure that out in the actual application? So when we're using, great, cool. So I'm looking for, in the API, we have a call that lets us determine which orgs Alice can create. Cool. So get user org. So we get the actual organization that a user belongs to. So in this case, we're going to get Alice's organization to understand which organization she can actually create users on. So I'm going to authorize the user for read permissions on the organization, which just means that like you're a member. And then I'll get that organization name, and then that'll get thrown back to the UI to draw the actual drop down that we're able to select that Alice can actually can choose that organization to create a user in. And authorize user here is just a little convenience function that uses the most generic authorized local function that we have. And what this does is, when I mentioned earlier that we were using the local Postgres instance for all of the authorization decisions, what authorized local does here is that I feed in the parameters that I need, which is, that it's a user with a given username, the permission that I'm checking, and then what resource I'm actually checking this on. And then this just spits back a query that will return a Boolean value, whether or not this operation is allowed for this user. And then I just query the database and I pull back, the allowed field of the response and return that. And that just shows us whether or not this is authorized. If it's not authorized, we throw an error. If it is authorized, we'll go through and actually get the user organization. Cool. So Alice can create users only in Acme because that's one that she's a member of. So we'll create a new user, Bob. And then we can see here that we have Bob. Now, if we go to Bob, Bob doesn't have very many permissions because he's just a member of a non-global organization. So he can read the organization that he belongs to. That makes sense. But he can't create orgs. He's not a global admin. Can't create users because he's not an admin. But he can't create documents. And we'll touch on the document stuff in just a second. But Alice, Alice is an admin, so she can create users. And we only draw, the section for user management if the user has the ability to actually manage users. So Alice, being an admin, can also, not only can she, add and create users, she can also modify user permissions. So we can change Bob's permissions here and edit that and save it. And now if we jump back to Bob, we can see that Bob now has a different set of permissions that he can create users himself. And the nice thing about this is that all of this happens only within the local Postgres instance. So the latency is low. You would have to make these kind of changes to your application data anyway. So the authorization is fast and things like that. So that's pretty cool. But we'll go back now and we will demote Bob from his glorious moment as an admin to just be a regular member. Cool. So that is a little bit of some of the ways that RBAC works in terms of writing your Polar policy and the way that you would use RBAC in your application to actually, affect, to affect user behavior. Cool. So now the second thing that we want to talk about is going to be ReBAC, which is relationship-based access control. So what we've seen so far in the Polar policy are resources with these brackets and then a bunch of stuff inside of it. One of the things to know about Polar is that this is actually just a convenience feature of the way that Polar works. This just creates a bunch of shorthand rules for us. And all of these things actually get blown up to being, there's like a longhand version of these rules. And I can show you that. I thought I had my IDE running, that would work, but I realize I don't. Cool. So if I go into the actual Oso environment, all of these rules for the roles and where roles and resources are used is that you can see if you just hover over one of these little shorthand rules, this is the full longhand rule that this gets shortened down to. So we can see here that if global admin, this is actually a has role rule with a predicate inside of it that ensures that the actor that we've passed in, there's a fact that exists somewhere, some authorization data that equates to has role with the actor's name and admin. So the way that plays out with ReBAC is that you can kind of guess that you're using ReBAC, or you're pretty sure you're using ReBAC once you start using the relations clause of the shorthand rules. So we can see here this is a little bit easier maybe on document, that documents have a relation to an organization called belongs to. So what this says is that every document has to have or should have a relationship to an organization in our authorization data somewhere. And we can, if people have questions about that, we can touch on that a little bit later, but I want to make sure we don't get too bogged down in the details of this because this gets just a little complicated. But what ReBAC does is that it allows you to kind of bootstrap a resource to have roles, for instance, that it kind of borrows from another resource. So here with the belongs to relationship or organization, we can actually refer to the roles on the organization resource. So you'll see here that the roles for my actual documents don't contain admin. Maybe you could say owner is kind of the equivalent of admin, but it's not the same thing. But I'm able to grab the presence of an admin role for a user on another resource, right? This is the way that we kind of create these joins within our policy. So what I say is that the user is an owner or has the owner role if they have the admin role on the belongs to organization. And this is the relationship in ReBAC, that I'm actually borrowing authorization policy structure based off of the relationship between the two resources. So the longhand rule is a little tortured and long. This is pretty easy if you poke through our docs to find an example of this. So the way that I would expect this to behave in our application is that every admin, every admin on the parent organization gets to behave like an owner over all documents. That is what this is attempting to say, is that if I'm an admin on the belongs to organization, give me the same permissions that the owner of a document has. So we can see this, that this can play out somewhat easily. So we'll pretend to be Bob, who we know is just a member. We'll create a new document called member doc. I'll submit this. I now have a new doc, and we can see all of Bob's permissions on document one, which is the member doc. And just everything is true, right? Bob is the owner of the document. He created it. He therefore has all of the permissions that you would expect on this itself. So I can change the title. I can call this members doc and save that title. We'll talk about this in just a second with ABAC, that you can change the public or private view of the document, or I can delete it. So I can also share a document explicitly with Alice. And I have a little note here that, she's an admin, and I can, express what her document role is, et cetera, et cetera, et cetera. But I can also just go in and impersonate Alice. And you'll see here that right away, members doc comes up. And this is because Alice is an admin on the organization, that she's able to then immediately get read access to all of the documents that exist within the entire organization. And then I come in here and I see that, Alice doesn't have I didn't share the document with her as the owner, but just by default, she's immediately given all of these permissions on the document. And to, prove to you that this is the way that this works, we'll call this an admin doc. And then we'll see here that, this is the admin doc that Alice owns, has all the permissions, everything's cool. So then we'll go back and impersonate Bob. And then Bob doesn't even have access to the, to the admin doc. But, you're like, I'm a little enterprising. I can guess what the URL for it is. And if I try to load it, Bob doesn't see this at all whatsoever. And that's a way that ReBAC can kind of influence the behavior of your application. So now let's go back and we'll pretend to be Alice one last time. And now we're going to talk about ABAC, which is attribute-based access control. And I like to think of these as the kind of, they're like data about the resource. It's a little confusing because you could call them fields, but it's not quite field level authorization. All of the authorization domain, some of the concepts, when you map them onto other paradigms like object-oriented programming, they get a little squishy. But we can talk about attributes as a piece of data that's maybe associated with a resource. So we have already seen that Bob cannot view the admin doc because he doesn't have any visibility into it. However, we do have the ability to set our documents to be public. And if we look in our policy at our documents, we have a special rule, and this is a shorthand rule that has a lot of flexibility. So we're able to use a kind of ABAC feature in some of these shorthand rules. But I can say that you have the read permission on this document if the doc is public. And now this is where ABAC lives, that we've created this predicate is public that just kind of exists out in the ether, and we hope that we're using it properly. So if the resource, and this is again a kind of convention of the shorthand rules that you kind of pass yourself into these, unnamed predicates as a resource. And so if it's public, if you have this attribute-based access control, and we're using ReBAC, that if you're a member on belongs to. So this is a kind of hybrid of ABAC and ReBAC. So like Hazal was showing the little onion and concentric circle of these permissions, all of these things interact and blend together in these complex ways. So if it's public and you're a member on the organization, you then can read the doc. So we saw that Bob did not have the visibility for the admin doc previously because it was private. But now if we set it to be public and go back, so we're Alice, now let's be Bob. And now we can see that Bob has access to the admin doc. So this is a way that you can have these kind of, I think fine-grained access control is maybe even its own piece of the pie. But you can have these kind of complex authorization rules based off of kind of whatever you need and whatever, suits your application. And yeah, I think that was the last kind of pillar of authorization that this app touches on that's easy to demo. So I think we'll call it there. But we wanted to open up the floor for any questions that people have.
Thank you, Sean. I'm just gonna share the Q&A section. So if anybody has questions, you can either unmute yourself and ask it, or you can ask in the chat and I can read them out. I saw one question in the chat about the VS Code extension Sean is using, and I know that Greg answered. We do have also VS Code extension, so you can also have your code look very nice.
Yeah, and it also includes the it's like the full LSP. So that was the thing that I was expecting to be able to hover over and just run the or demonstrate the expansion of the shorthand rules and the little brackets into the longhand rules. The LSP supports that in VS Code. I just think that I think my LSP crashed because I was running some sort of development version.
I see a question from Eric. Yes, you can ask anything about also implementation, questions about our team, authorization models, whatever you want.
What's on your mind, Eric?
You can see those fingers furiously move.
Typing indicator.
Okay, Eric wrote, I can see that Polar implements policy as code, which is great for Git history, but is there a way to get the specific assignments in state logged or reported?
Yeah, so part of that depends on where the authorization data lives. So one of the nice abstractions with having the policy, the control plane operating one way, is that the actual authorization data for the state of these things can just live within your database. So there is logging for some of that. I can show this here where I want to say it's the logs that we can show you. I've used this. Let me share my screen. So I have used, yeah, it was running a little bit slowly. I've really abused this account. But what you can see what the authorization requests are. I don't know if that exactly answers your question. This doesn't log the state of the database. It doesn't log the state of your authorization data, but we do log what the actual requests are that are sent to us. If you are
Eric,
using,
I'll add one thing, which is probably not yet documented because it's only something that we built pretty recently. But we have added the ability to add logs for not just who requested access to what, but also what changes were made. So if we think about what you're seeing on the screen right now is like the read side of the equation. We have recently rolled out and already have customers using logging for the write side of the equation, WRITE. It's just not yet documented and only currently available via the API, not in this pretty little UI. But you can expect more on that soon.
And Graham, that would be if you're using centralized authorization. Is that right?
That does sound correct. And I would probably want to follow up with the engineer responsible for building that to answer even more specific questions. Yes, one such engineer is confirming, yes, that is correct.
Cool. I saw Tyson also had a question. You made reference to
let me
user-defined
read it.
custom roles.
You made reference to user-defined custom roles. For example, maybe we would make a user interface that allows an admin to create named roles that doesn't exist in the policy. I know it's kind of complex, but is there a plan to publish documentation on how to do that in Polar?
Yeah, there actually is already documentation on doing that. If you go to the Oso docs, it is the magical keyword is custom roles. And we have docs on how you can one feasible approach for actually doing this. So whenever you're looking at these examples, often they rely on Polar's built-in unit test framework, which is just, this little test keyword with some brackets inside of it. And then inside of that bracket, there's another setup keyword. And this represents the authorization data that needs to be present in order to make the policy actually use these things. So if you look up at the policy up here, this highlighting thing is hard to demo, but you can see here that we just have an actor type called role, which is then referenced here, where you can see this role is actually used in this has permission check. And this does a kind of join against has role relations. But you're able to define, and grants permission. So it's has role and grants permission. So you're able to define in your authorization data which permissions a role grants. The kind of catch with this, or the corner that you might run into, is that we don't have an example of how you could define arbitrary permissions, but you can define arbitrary roles. But in some ways, that makes sense because the resources in your application only have like a certain number of things that can be done to them, and those need to be handled programmatically. So you can define roles and assign, the known set of permissions to those roles in whatever configuration that you want.
I also added the custom roles link into the question, so if anybody wants to see the documentation, they can click to it. Follow up, can I programmatically extract the permissions for a resource, or would they need to be hard-coded into a UI for granting such things?
Yeah, so in my sample app, I was just a little lazy because you can do what you're asking with the policy metadata. So you can, through the Oso SDK, fetch the policy metadata. And what you get back, for instance, the metadata object is going to have actors and resources, and then it's going to have some sort of delineation for all of the different resources that you have. And then inside of that, it's then going to have things that are defined as, in the shorthand rules at least, for, like roles and permissions and probably relations. So you should be able to kind of string that together in a way that you can dynamically get these things from your connection to Oso Cloud.
Thanks, Tyson, for the question.
Yeah, these are good questions, like the custom roles and getting the permissions and things like that. I actually wasn't aware that that existed until I started building the app. It hadn't occurred to me that you'd want the kind of static list of those things to populate your UI. So really good questions.
You have come a long way in a year. Thank you. Ash, do you have any questions?
It's more like, Ash, do you have anything that you can teach us?
You talking to me?
Yeah.
Damn, put me on the spot. No, I was just listening, and I think it all makes a lot of sense to me. We've been using all of this in our application, attributes, relationships, and roles, and been able to build some pretty cool stuff with it. So it's just good to come in and sort of reinforce some of those concepts. So I don't have a question. Sorry, I realized that was your question.
All good. We have one question in the chat from Josh. I have a similar question to Tyson. We have 115 canned permissions. We have 10 canned roles. Our admin section of our app allows power users to create custom roles from these canned permissions. It sounds like also will allow for this type of flexibility. Correct. Yes, it is correct.
Yeah, the one caveat with that, if they're all canned, is that you would need a way to get those canned permissions into your policy, I believe. That should be achievable, but that is that's the one, it's not really a gotcha, but that's the one, kind of complexity, is managing how you want to retain all of those.
Last question from Josh. Also, when mixing and matching the authorization types, how difficult is it to test when we are creating holes in our security policies?
That's a good and tough question. I don't know if anybody else from Oso wants to speak to that. I think that it's possible to always exhaustively test your policies.
I'll provide a
Yeah,
high level and potentially satisfying response. So I think there's sort of like two ways that we would think about you ensuring that you're not creating any holes in your policies. And so the first one would be by doing a healthy amount of unit testing, which I think Sean was showing a little bit of that, but there's probably a lot more that we could share. And certainly after this, we'll drop some docs in the Zoom about how you can write unit tests across your policies the same way that you might be testing for anything else in your code base. So that's the first thing. And the second thing, which I will also drop a doc for, is Oso provides a tool called Explain, which could be useful for kind of like poking around and seeing if things are behaving the way that you expect them to behave. And so basically the way that that works is, given a set of rules that you've defined in your policy and given the data that you have in Oso Cloud, you can say, hey, can this user do this thing on this resource, as an example? And it'll spit back to you not just a response of whether or not that would get resolved to yes or no, but also why. So it'll show you all the different ways that a person could have gotten access to that particular resource, and which, if any of them, returned as true. And so we find that those two strategies in combination tend to be pretty effective. But happy to go into more detail if that would be useful. And I'm now going to go look for those docs.
I'm also going to share the general how to model these different type of like RBAC, ReBAC, and ABAC and Polar. And I'm also going to send a link so that you can join our community Slack, where you can share questions, ask things, interact with other people who use Oso. I also want to just generally thank you for everybody for joining, and please look out for our future webinars, and we will also follow up in an email with a recording of this webinar, as well as some more documentation meeting is useful. And thank you, Graham, for sharing the tests and explain sections of the documentation. Thanks, Hazal and Sean.
Thanks, everyone.
Oh, Trustport has one more question.
One last question. We have 4 minutes. One more. Sean mentioned in his demo that the processing of his test account was slow. We will have tons of roles, permissions, and mixed authorization types without service degradation.
Yeah, the thing I was saying was that pulling back the logs was slow. I unfortunately am too ignorant of the actual internals of that to know anything other than I was attributing the slowness to the fact that I have really used the I've really used that account a lot. So I don't know if I just probably have many gigabytes of logs and they just took a second to pull back. It wasn't that the actual service was slow, just pulling the logs back out into the UI had some latency right now, but I don't actually know enough to identify the cause of it.
In practice, by the way, we find that most people will be using some like that logging interface for things like debugging, but for a lot of the, there were some questions earlier about like, write logs and stuff like that. We find that a lot of our customers want to export that somewhere else. And so I think in practice, many of them are using it in that way.
And Tyson said in the chat, we have an increasing complex policy with recursive structure and nearly 1 million facts. We have not had any performance issues in the year that we've been using also. Awesome. I think we answered all of the questions. Thank you so much for joining again. And thank you, Sean, for presenting too. See you on the next one.
Thanks, folks.